So today I'll talk to you about a new open source project. So I was at open source 20 years. One of the things that I love about open source developers is how they work back from a problem they're trying to solve. And the problem that lots of developers are trying to solve in a lot of time is the authorization. Authentication, over the last 20 years, it's been most solved, it's standardized, we can do it for like easy. But think about authorization. As we build applications, authorization is how, as we build onto user systems, we are able to make sure we protect the resources so that only those users who are supposed to access have access. And it's common that is still not solved. This is OLOS who do security. These are the application security checkers. For the last 3 years, authorization's been the top in Cedar. And so I guess the question is, why is authorization so hard? And the reality is that the actual theory of authorization is actually well understood. Okay? Over the last 30 plus years I've been working in tech, we've had different forms of authorization. So role-based authorization, attribute-based authorization, and relationship-based authorization all come along over the last 20 to 30 years. But they're very hard. Okay. Why are they hard? It's because that, well, I first started doing technical applications. It was going to be working one program to manage. That made Java, ready, .NET. And as long as we kept monitors, you could use frameworks and the authorization spin frameworks. And it was pretty easy. But if you think about head issues about the microservices, they're built in different managers. How do you make sure you have authorization is consistent of those complex applications? And it's hard. And what expect a lot of developers to do is create code like this, okay, where you build the authorization logic into your application. Now, I'm not going to ask you to recognize it, but I know I run code like this. There's no shade. There's no shade, okay, in that. But it's just what we've done. And of course, as developers, there comes a time where you think, this can't be that hard, right? No, it's power of flag bomb. It's like, sorry, I was giving this to you, so I don't want to use it. It can't be hard, right? So to build an authorization system, put your hands up if you attempt to build an authorization system here. Oh, yeah, you're my people, I think. So you know what it's like, and it's hard, right? Orderly access control, hours they use, the mathematics is incredibly complex. But when you think about the characteristics of what you want for an authorization system, you can summarize them in these 3 things. The first thing is that it's got to be performed. If your application is doing authorizations, you don't want to slow down the application, you don't want to slow down your customs. You need to make sure that if it does authorization, that it is actually doing what you want it to do. So I know when I've written authorization systems, I would not bet my house, I would not bet my car, I probably wouldn't even bet my laptop on whether it was accurate, okay? Because it's really, really hard to do. It's best endeavor, so you try, you peer your code. And then the 5th thing is that when you write this code, okay, and you put it in application sheets, how easy is it for someone else to look at that to make sure that the authorization is okay? And the answer is that when you do it, it's very difficult. So these are 3 characteristics of building your own and why it's so hard. So we're in a situation where we having to build applications and there've been no kind of like good solution. And a few years ago, a number of open source projects started appearing. So OKA was probably the most popular. Who really is used as OPAs? Okay. So this is a project that allows you to find authorization as pretty handy, but there are challenges with it, and specifically challenges around performance and analyzability. So at Amazon, we buy Techno Triangle White, work backwards for these goggles, and so yeah, so we open source this project last year, or Cedar. Has anyone heard Cedar game? 1, 2, okay. Twice. So by years, hopefully shared knowledge about what is one of my favorite open source projects. And what Cedar is three bits. It's a language that you can create authorization policies. It's an authorization that allows you to take authorization requests, analyze them, and then tell you whether someone's got permission or not. And it also provides tools to help you assess the access of your policies. So the three fundamental things you need as a company when building authorization. So we'll look at each detail of this. First one is the authorization language. And so C uses something called policies. So you write policies, and then policies are submitted to an authorization engine. But what do policies look like? And how does this actually change how our applications would look like? Well, it changed it because from that previous code we had, we can now move to a consistent is authorized function, which points to policy. So now we have the same function called, whether it's written in Python, in Go, in C#, etc. And there are three pieces that make up a policy. The first one is the effect. Then there's the scope, which talks about actually the impact of what your contract cover within the effect. And then there's a conditional, which is optional. So I'm going to dive into these in a little bit detail, right? So this is kind of typically what they look like. Now, one of the things that you might ask is why we split out thing at the top to thing at the bottom. And when we launched Cedar, we ran inspired as customers master how they wanted policy to look like. Again, a number of different ways. And what they say is this is the third format, splitting out into a compulsory section top of head, and the conditional we call policy bottom core thief conchit. And I said it made it easier to actually erect and read and understand these policies. And our engine OEA, right? So this is a Cedar policy, right? And to do the same thing at OPA, you need to buy all the codes at the bottom to do the same thing, right? So this is one of the reasons why we spent a lot of time building Cedar to try and make it simpler than the existing open source projects will obey. But hopefully some of the places do all thinking now is that if we create policy language, okay, how does that policy language know about our application, right? So all you have to do, how you see it, is you have to model your application. And what you do is you effectively define entities and schemes. So entities are the things in your application. So I'm going to be sharing up a little demo photo app that the bike talk. So if you want to see the demo such in action after the bike talks. But if you think about the entities you have that photo sharing application, you've got photos, photo hours, got people who are creating those photo hours. And then you've got the schema, which is the structure, the defined structure of those entities. And so these are two characteristics. When you take both of those together, you can actually start putting them into good policies. So now you can use the policy elements to tie what you bear like patient to authorization systems. So this is a couple of a schema aspect, and this is what the entities look like. So you have to be this real code. But when you use what you've done in your code, you can then call these out into permissions. So the effect in a Cedar only have two effects, which is permit or forbid. Okay, and within the effect, you define the scope. So what is the total resource that you want to protect? And this is defined by the principal, i.e. the set of users, the actual, so what is it you're trying to do, and then the actual resources, legal application. Now, the condition, which is the attribute-based component of Cedar, allows you to then fine-tune add additional characteristics. So a good example might be that you might have, in a photo sharing application, you might have a location and make your photos as a tag. You could create policies that only people in a certain country can view or have permission to view your photos. Cedar allows you to group some immense bits well together, and you can define namespaces, which means that you can have, multiple applications, have a by, have a policy. Now, in these examples I'll show you, they're very similar, okay? And typically you would not do that with a application. what you would do is you substitute the real entity that the end user has, so for example, me in the job dove, with or group, and you made a unique reference. So the first take the extract the sticker might change, so it might change the name, but you don't change the underlying the UI key. So policies are pretty straightforward to author, to create, but then you can actually use them. And this is where the authorization comes in. So the authorization engine takes a few inputs, takes policy you created, it takes the application schema entities that we got from our application, and then optionally also takes context. So it might be, for example, HTTP headers, it might be your IP address, it might be an NFA token. And all those parameters are put into the authorization engine. The authorization processes that and it gives you 3 outputs. So I know there's 2 there, but it will either say allow, deny, or error. So the third one is an error. And I'll tell you why as well, the error. Now, when it comes to the Cedar policy evaluation, always defaults to deny. So if you don't have a policy, or if you're explicitly mentioned in the policy, you will not get access to your application resources. But there's a question I'm hoping someone you are thinking about. It's that, I talked about earlier about when you build your mobile authorization engine, how can we trust it? And that's an important characteristic. If you want to use any open source authorization engine, how can you be sure that it's always going to be giving you the correct authorization decision? And for that, we need to go back to high school or school. Who recognizes this? Yeah, a few people are like, honestly, you thought you'd never see this again? Aha, wrong. Now, the interesting thing about it, okay, is that we cannot live our lives today without this theorem, okay? If you live about engineering or architecture, they use this to do lots of different things. But you spent years building a proof in order to come up with a very, very simple algorithm. And so there is a similar form in software called automated reasoning. An automated reasoning is how we can apply the same logic, building theorems, building proofs, but this software. And a good example of authorization is this. Any explicit denial in any policy logic overrides in and out, okay? So it's the statement that any authorization should have. And the good news is that we've applied the same principles that you said that would create Pythagoras' theorem to software using call reasoning. So what we can do is we can turn this statement into something that's more language friendly, okay? And then from that, we've then used all the full reasoning tools out there. Now, there are quite a few TLA. There's this one is specifically Daphne, which is what Cedar was originally built in. And it allows us to start modeling that statement in Daphne's language. And this is important because Daphne provides us with some tools to actually now test the proof. Now, in this example, okay, to the previous slide, if we want to turn this denied language into a rule, we simply have to do pattern matching, evaluating strings, okay? And this might be a way to do this in Daphne. But if you think about evaluating strings, actually by complex paths, because you drilled down into lower layers, so evaluate, you need to make sure you can deny something, you need to match a statement means to match efficient, also be a match efficient means to do string evaluation. And this is a qualitative lexicon, keep going. So earlier I was asking a few people about whether there was some colored words in Polish, but in German, you can write Strasse, 2x, S-T-R-A-S-S-E, or S-T-R-A-S-S-E. They both mean the same thing. If you author a policy, right, they should both give you the same access, right? So this is why doing things like this is actually really complicated. And so what these tools allow you to do is actually create a software development lifecycle that allows you to start building proofs and testing proofs at scale. And you end up with software that is provably correct. That's a really important characteristic, right? Because normally when we buy software as best endeavors. But now, with something as important as authorization, we can actually move to a situation where we can prudently correct, you could have confidence that your authorization decisions are prudently correct. So the question is then, why do we do this? Well, the first one is trust by, because in authorization, you need to make sure to guarantee that if you're authorized to do something, that authorization is correct. But as it turns out, there are some other benefits to doing it. Even though it takes longer to do, once you've got the proofs, you can actually iterate faster. So IAC is the system that universities do authorizations. We implemented this products, and we went from doing 2 or 3 updates a year to monthly updates. The other thing that allows you to do is that allows you to optimize code, test the code. You can do, is this code faster than the older code? And we were actually able to improve the performance of IAM by 65% using this approach. And so ultimately, the reason why you would do something like authorization, for authorization systems is you really want higher confidence. And we use them in IAM, and this was 6 months ago. We're now at 1.33 billion requests per second. So when you're running at that scale, you need to make sure that your requests are okay. So that's kind of the background as to how we created Cedar, but we took it one step further, and we created a new methodology called verification guided development, which takes a reference implementation, which was from Daphne, we moved to the, and then we create in Rust. So I know it's the Python conference, apologies, the Python that comes from the library, because we wanted a memory safe package, right? And so what we did is, because we know the performance of the tool that's created Daphne is not going to scale to what we need. So we create software both, and then we built a testing system. And then we literally test using fuzz testing 100 million requests. And the idea is that we know the requests in Daphne are always going to be true. But when we run the same test against the Rust code, the test is always the same, whether we identify the bug in our Rust code. So we keep doing this till we get no differences between the two. And then we've got a release. And it's super easily, there's a blog post, you could dive deeper onto this. But the importance here is that we've got a process that allows us to create code that is trustworthy. And also scale. So this is some benchmarking they've done that shows how Cedar compares to other open source authorization frameworks. So the difference between those and ours is that as you scale it, we don't have any increased latency, whereas others like API, for example, we see start getting increasingly poorer performance. A third aspect of Cedar is analyzability, okay, and how is table policies or authorization policies. And to do things you can all leverage easily. You could do things like test performance. So do people have the same enough of access to my application resources? Or I could start using this to run the script to rationalize and simplify my authorization without risking people losing access. You do that through using the command line tools you had to Cedar to do that. So Cedar provides effectively a very performance authorization language which is provably correct, and it gives you tools to do authorization. Now, there's no time for me to do a demo here, so I'm going to do a 5-minute demo at the light subsector. You should actually see the Python code that I have on my machine and see how you can use Cedar for with Python. Check out the guided talk. If you're interested in know more, get started, there's a whole bunch of resources. It's an open source project. It's still in an active development. So RFCs are still being created to change and add new features, change the direction of the language. For languages that aren't supported out the box, there's also a sidecar called Cedar Agent that allows you to effectively create all your policies in here and then call iteration key requests. And I'll share this slide. There's a link at the DX where I share slides. There's a very active spec using as well. But normally what happens when people start using Cedar and they get very excited and they want to know what's part of production. So how do you actually take sort of just a project that you're looking at to actually that going to move it? So the first thing is that there are a bunch of development tools you can use. So if somebody will have installed the understand Cedar syntax and analysis that have latex, so when you're creating your policies, your entities and your schemas, it tells you a fair about there's columns for them. What we find a lot of people do is now finally moving authorization into their CI/CD pipelines, because you've got Cedar-defined policies, you can actually now build that into your CI pipelines and use online tools. You can actually run tests, and if first guess right, you can actually stop your project authority. So it means that you don't accept people increase those on access. And if you want to have a managed service, that there are a number of people who do this. So there's StrongVM, there's PerfBio, AWS has OpenServerFush. So there's a whole bunch of people you can help with that. Now there's the code to do the one talk is there, and there's a really good talk about how we use formal reasoning within AWS. And so make sure I've got time for questions. If you want to spin slides, there's a short survey, I think 5 or 6 questions. We will copy a slide. If you want to follow up, ask questions afterwards, these are my socials. And with that, I think I've got time for questions. And don't forget, like talk, if you want to see it actually running, it's got a Flask application. You just use Cedar to protect a little photo application. You can actually see it in real life. So, any questions?
So, if you didn't get, you can visit Lighting Talk and Season Hemming. And I need to hear, so you all must deserve. So, this.
Okay, so how does Cedar work with LDAP?
Does it work with
LDAP.
LDAP? Yeah. So, in what way?
Like, let's go back. For me, like LDAP, like let's say you have a bunch of like users defined in LDAP, like let's say different roles, and based on that information, you want to you give them different levels of access, and we want to pass it through Cedar.
How would you do it? Yeah. So what you would need to do is you would need to. So the way Cedar works is it uses entities as their schema. The entities are effectively the things in your application, so users, groups, resources. So you would, if you were doing that today, you would need to coded you up, you would have to refactor your application to extract the data from your LDAP into entity formats or a schema. And then what will happen is when you do should show you what it is like. So, I have to can't see it. So I can't show you because the screen that you share the screens. Apologies, I can't do that. Come to the left hand, I could show you, but you would effectively write the code, and then when you do all these authorized requests, as part of these authorized requests, you submit the entities, the schema, and the politics. So I want to drive. It's not like to do this. I want Keyscape P2. Keyscape provide ILAN. I have and that's sympathetic bias. Donkey doesn't use it. I'll use the same thing. And I was going to extract users, groups, create policy entities, and do that. But I haven't got around to it yet. But it's on my to do this. But yeah, it should work. But it's not going to work without you having some name phrase. So yes, you can put it in, but by the code you take data out and they submit it as part of your authorization requests. For you.
So, thanks a lot for the question, and I hope to will fly to Garden and ask more questions because it's for both it will be very useful. So, thanks a lot, Ricardo.